Okay, this is worksheet 8.1, and in this video I'm going to look at problems 2, 3, and 4. And the instructions tell us choose an appropriate method and solve either by factoring or by quadratic formula. So we'll look at how to decide which one to use, and then we'll solve each problem. So in number 2, the first thing you can do is, if you want to factor it, first you need to check whether it's factorable. So to check whether a quadratic is factorable, you can do the diamond, multiply a times c, and write that on the top. B is going to go on the bottom. And then if it is factorable, you should be able to find two numbers that multiply to 2 and that also add to -9. In this problem, there are no two numbers that would multiply to 2 but also add to -9. So I'm going to go ahead and scratch this process and instead solve it using the quadratic formula. So the quadratic formula, I'm going to go ahead and write it down here at the top, is x equals -b plus or minus square root b squared minus 4ac, which is all underneath the radical, and then all over 2a. In this quadratic, the a value is equal to 1, b is equal to -9, and c equals +2. So if I take those values and plug them into the quadratic formula, we get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So if we simplify that, this becomes +9 plus or minus +81. -4 times 1 times 2 is -8 over 2. So then we get 9 plus or minus the square root of 73, and then divided by 2. When we look at this answer, we should ask two questions before we decide to stop. One is whether this radical can be simplified. If we factor 73, 73 is a prime number, so there is nothing that we can take outside of the radical on that. Also, none of these can be reduced, so this is our final answer. So on number 2, we used the quadratic formula, and we got x equals 9 plus or minus the square root of 73, all divided by 2. All right, let's look at number 3. On number 3, let's go ahead and first check whether we can factor it. So we have on number 3, 7x squared minus 6x minus 1. So if we try the diamond, the top would be a times c, which is -7. The bottom is -6. So we need to decide, are there two numbers that would multiply to -7 but add to -6? So here, if we multiply -7 times +1, that works. So this is factorable. So I'm going to go ahead and decide to use factoring on this one. So we have 7x squared minus 6x minus 1 equals 0. The reason we did this is because we want to split the middle term into two parts. So I'm going to rewrite the first term and the last term as is, and then the middle term we're going to split it into two parts. -7x and +1x is what these two numbers help us with. So then we're going to factor by grouping. The first group, GCF, is 7x, so I'm going to take that out. And the GCF of the second group is just 1. So if I wrote this in factored form, one of the factors is this, the one that's the same. The x plus 1 is one of the factors, or x minus 1 is one of the factors. Whatever you have left is the other factor, 7x plus 1. By solving this, I can find my solution. So x minus 1 equals 0, or 7x plus 1 equals 0. That means x equals 1, or x equals -1/7. All right, the last one we're going to do right now is number 4. So again, let's first check whether it's factorable. If it's factorable, we can factor it. If not, we'll use quadratic formula. So we have 9x squared plus 4x minus 2. 9x squared plus 4x minus 2 equals 0. Let's check whether it's factorable. So we have negative 18 and positive 4. There aren't any two numbers that would multiply to negative 18 but add to 4. So I'm going to go ahead and scratch that, decide to use quadratic formula. So let's go ahead and plug in a equals 9 this time, b equals 4 in this equation, c equals negative 2. So I'm going to plug that into the quadratic formula here. So negative b plus or minus the square root of b squared minus 4ac over 2a. So if we simplify this, we get negative 4 plus or minus the square root of 16. This multiplication has two negatives, so that's a positive 8 times 9 is positive 72 divided by 18. If we add these terms, we get 88. Now, when you're looking at this answer, we need to look at a couple things. One is the radical. We can simplify this radical. So in order to simplify square root of 88, we're going to first factor 88 into its prime factors. So choose any two factors that multiply to 88. So I'm going to just use 2 and 44. And then continue factoring. So it's 4 and 11. This can be factored further into 2 and 2. So these numbers are the prime factors of 88. So I'm going to rewrite square root of 88 as the square root of 2 times 2 times 2 times 11. So when you're simplifying a radical, for every two of the same factor, one can come outside of the radical. So for each of these pairs, this is a pair of 2's, one of them is going to come outside of the radical. The reason for that is because you're really just taking the square root of 4, which is 2. There aren't any other pairs of numbers, so the final simplified answer is 2 on the outside of the radical. We have a 2 and an 11 left inside, so if you multiply those, there's a 22 left inside the radical. So if we rewrite this answer, we get negative 4 plus or minus the square root of 88 is equal to 2 root 22 divided by 18. And if we look at this, this can be simplified even further because each of these can be divided by 18 and we can reduce these. They're all divisible by 2. So if I divide all of those by 2, negative 4 divided by 2 is negative 2. 2 divided by negative 2 is just 1. And then 18 divided by 2 is 9. So our final simplified answer is negative 2 plus or minus root 22 over 9.